Hello, my chemistry friends. This is Mr. Foley, and welcome to the last lecture, 7.3 for our heat unit. So, we have to know the tough thing that we talked about before. Heat flows from hot to cold. We know heat is Q equals mc delta T, where Q is heat, M is mass, C is specific heat, and delta T is change in temperature. If hot water touches cold metal, remember heat flows from hot to cold, the hot water loses heat, so it's negative Q. The cold thing gains heat, so it's positive Q. And they equal each other, so we'll set up right here. Liam, a student I had before, peed in the kiddie pool this summer and every summer. He was a lifeguard. He talked about how it made him happy. Not really about being happy in a kiddie pool. If 2,000 grams of water at 19 degrees Celsius had 750 grams of urine at 37 degrees Celsius added to it, what is the final temperature of the mixture? Assume Canadian urine has a specific heat of 1.00 calories per gram degree Celsius, just for like water. So what we do is we have a hot equals cold. And I throw out here a negative sign that I'll worry about when I want to worry about it, okay? So we have what? Hot urine, and cold water. So I'm going to leave this negative sign out here. I'm going to do, oops, not going to write Q. I'm going to write MC delta T equals MC delta T. So the left-hand side is the hot air in there. Okay, so Liam peed in the kiddie pool. I've got 2,000 grams of water. I'm looking for the kiddie pool first. Not kiddie pool, for the urine first. Had, oops, here we go, 750 grams of urine. So 750 grams of urine. The specific heat of urine is 1. The change in temperature, remember how it's going to be T sub F minus, make my parenthesis better. Oh, I give up. I tried to make my parenthesis better and I failed. T sub F minus the initial temperature of urine is 37. Okay. Equals cold water. Okay, so my negative sign hanging out here. Cold water. The mass of the pool. The pool. Specific heat of water is 1. And T sub F minus 19. All right, so let's do a little math. Do a little math. Okay, so this means I would have, I'm going to leave my negative sign out here. Oops, I'll leave my negative sign out here. 750 T sub F minus 37 times 750. 27,750 equals 2,000 T sub F minus 38,000. So again, I distribute there. I didn't worry about multiplying by 1. It's like kissing your sister. It doesn't really do anything. But now I have this negative sign out here. I'm going to distribute my negative now. Negative 750 T sub F, positive 27,750. So what I'm going to do now is I am going to collect my terms. So I'm going to put all of my terms, all my T sub F's on the left. So I'm going to subtract 2,000 T sub F's from the left-hand side. So I'm going to have negative 2750 T sub F equals, and I'm going to subtract 27,750 from negative 38,123 minus 27,750 is negative, big number, 65,750. Okay, do my math over here. So now to solve for T sub F, I'm going to divide both sides by negative 2750. So T sub F equals negative 65,750 divided by negative 2750. And I'm hoping my number is between the body temperature, 37, and the temperature of the pool, 19. And when I do that, I get 23.9 degrees Celsius, and I'm happy. Yay! So again, hot minus cold, and then don't forget to distribute your negative. All right, let's do another one. In the 1900s, this is for real, people would ship ice from up north to their houses for air conditioning. If 6,500 grams of ice melted, what would be the final temperature of the room if the room was at 30 when it started, right? And the mass of air is 12,500, the specific heat of blah, 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 blah. Okay, so this is talking about the instant that 6,500 grams of ice melted. So what's the hot thing? Well, I got hot air. That's going to be negative. And I'm going to have cold ice. You're as cold as ice. Boom, boom, boom. willing to sacrifice my love. So T sub F minus T sub I equals MC T sub F minus T sub I. But, oh no, if you copy that down, you're going to hate it. I've got cold ice, but my ice is not MC delta T'ing it. My cold ice is melting. Oh no! So the energy change is not MC delta T, it's M delta H fusion. So all that energy is going to come from the melting ice. So here we go. Mass of the room. Negative. Mass of the room. Mass of the room. Mass of the room. Mass of the room. Mass of the air in the room is 12,500. Specific heat of air, 1.44. T sub F. Oh, that's what I'm looking for. Minus T sub I. How hot was it? 30. That's toasty. Actually, I think that's toasty. Mass theory. Convert 30 degrees Celsius to Fahrenheit. 86. That's kind of toasty. Equals the mass of ice. Now notice, this is not the same mass. Not, ooh, you dirty dog. Not this mass, because we're talking about ice. All right? So 6,500. And then the heat of fusion for this is 80. And I look at that sheet that has everything listed. Okay? So let's do some math. I get rid of this crossed out number that shouldn't be crossed out. So here we go. So 12,500 times 1.44 is 18,000. 18,000 T sub F minus 30 times 18,000. 18, 1, 2, 3. Enter. 540,000. Oh no. Well, that's interesting. 540, 1, 2, 3 equals 6,500 times 80, 520,000. 520, 1, 2, 3. Okay, so I'm going to solve for my T sub F. So 18,000 T sub F equals, I'm going to add 540,000. That's 520, 1, 2, 3. Plus 540, 1, 2, 3 is 10601, 2, 3. Now I'm going to solve for, oh, come on, man. And then I'm going to solve for T sub F. And the way you solve for T sub F is dividing both sides by 18,000. So T sub F equals 106, blah, 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 divided by 18, 1, 2, 3. And I get T sub F equals, changing my screen again. That's not what I wanted. Gives me 58.8 degrees Celsius, which does not sound good. I started at 30 and it got warmer, and that's not good. I know what I forgot to do. Do you know what I forgot to do? I know what I forgot to do. I forgot to distribute my negative sign. There's my negative sign. There's my positive sign. Oh. So let's take a look. That didn't make sense. When my big chunk of ice made the room hotter, shame. So let's do this with the corrected in red, maybe. So this would be negative 18, 1, 2, 3 T sub F equals 520, 1, 2, 3 minus 540, 1, 2, 3 equals negative 20,000. So now I'm going to divide both sides by 18,000. So negative 20,000 divided by negative 18,000 is 1.11 degrees Celsius. Woo, doggies. That means it's going to be chilly. Chilly, chilly, chilly. And that means we're all done. Toodles.